You are listening to the Hydrac Podcast. In each episode, we share our knowledge with you in topics related to hydraulics and automation and control, from the basics to the current trends. Stay tuned. Hello everyone, welcome to this episode of Hydrac Podcast. I'm your host, William Shaw, and on this episode we are going to talk about the Australian regulations for hydro-pneumatic accumulators. And here in our studio, I have with me Mr. Ali Nejat. Ali is a mechanical engineer with over 15 years of experience in the fluid power industry. He is also a certified pressure vessel inspector and he works for Hydrac as a National Development Manager for Industrial Hydraulics. This is part 2 of our hydro-pneumatic accumulators. So Ali, I'll hand over to you to give us a quick recap on the owner's responsibility that we briefly talked about in part 1.
Oh, hey, hello, William. Thank you for having me again. Well, last time you spoke about quite a number of different regulatory obligations and what is it like to have a pressure vessel in our plant and what are the owner's responsibilities in terms of dealing with that particular item of a plant being a pressure vessel. So we spoke about all the regulations around a pressure vessel being, design registration, item of the plan registration, documentation system and everything. And we left it at owner's responsibilities. And for you as the owner of a pressure vessel in your plant, what are the things that you have to tick off in order to comply with the regulations in place? But really it comes down to one simple point. The owners have to ensure that the regulatory requirements, including design registrations and item of a plan registration, are adhered to. On top of that, they have to have a management system sufficient to ensure the continuing integrity and safety of pressure equipment. Now, what does that mean? They have to have a full control over all the documentations in place around the pressure vessel. They have to know where those pressure vessels are located, if they're identified with a particular number. They have to be able to track all the documentation pertaining to that particular pressure vessel, including the inspection documents, including the design registration, including the manufacturer data reports, drawings and everything. So really, it's up to the owner that if an inspector or a representative from WorkSafe shows up at their plant and asks for documentation pertaining to a particular pressure vessel, they have to be able to pull it out from their archive and present that in a presentable format, obviously. So an important part of the documentation that the owners will have to have in place is the inspection documents. As per a number of different standards, and most importantly is 3788, which sets out requirements for in-service inspection of the pressure vessels. They have to run a number of different inspections on a particular plant, and also keep records of those inspections as part of a documentation, and they have to be able to present it at any time to whoever is demanding to cite those documents.
So Ali, how often do you have to undertake these inspections, and who would normally undertake these inspections as well?
Yeah, that's a great question. So again, AS 3788 sets out the requirements for inspection and when and how and by whom the inspections have to take place. So in terms of how often, there's quite a number of different intervals and occasions during which you have to perform an inspection. So let's start from the beginning. When you put a pressure vessel in place and when you install and commission it, prior to pressing the start button, you need to get an inspector involved to run what we call a commissioning inspection. The commissioning inspection is done for the owners to ensure that from the point of transport, let's say Hydrac supplied a hydraulic accumulator, before it gets to the side, 1,001 different things may happen. They may get a dent, or the pressure vessel may sit outside under some weather condition, and it may rust. Or it might be some falling object creating a gouge on the pressure vessel or anything. So you have to engage, unless you're a competent person, you have to engage a pressure vessel inspector to have a look at the pressure vessel, first of all, to ensure the integrity of the vessel, and also to make sure that that particular vessel is intended for that application, right? So this is not very much the case for hydraulic accumulators, because they're typically mounted onto hydraulic systems, but this is mainly applicable. It is still applicable to pressure vessels as well, but it really much comes to effect when we talk about larger pressure vessels, or boilers or air receivers, which are critical items of the plants. Then we have the periodic inspection. So once the pressure vessel is in place and it's working, then you have to run periodic inspections on certain intervals to ensure that the integrity of the vessel is maintained again, on certain intervals. Then we have inspections following serious excursions or damage to the vessel. Let's say there has been a fire, right, in a refinery, or there has been some sort of flooding in a factory, right, that has caused some rusting and corrosion across different items of that plant. Then you need to actually engage an inspector again to tick through all the boxes relevant to the integrity and health of a pressure vessel, and make sure that your vessel is intact and still fit for purpose and good for operation. Then we have inspection for proposed change process in service condition. For example, if you've been using a hydraulic accumulator on an oil service, on a hydraulic power unit, right? And now all of a sudden that power unit is redundant, but you decide to choose that accumulator, to decide to use that accumulator on a water service application, right? So that's a bit of a change in process, correct? Because the medium has changed from hydraulic fluid to water. Water has a bit of a corrosive nature, and it can have an impact on the health of the vessel. So again, you have to engage an inspector and get a sign off that vessel is in fact suitable for that particular application. Next one is inspection following repair or alteration, and these inspection regimes, they've been suggested by AS 3788. So from regulatory point of view, you're obliged to comply with this inspection regime in a way. Inspection following repair or alteration. Let's say you have a gouge, or you have some corrosion on a internal surface of a pressure vessel, right? Then you get an inspector, and you do a repair on it. You clear the corrosion, if you want to paint it, or if you want to weld a supporting plate around the gouge, or anything as such. Once you're done with your repair, then you'll have to engage a pressure vessel inspector to check your repair process and sign off on, yes, this pressure vessel is fit for purpose, and you can actually in fact use it. Then we have the inspection of idle equipment. That's also quite an important one. Maybe sometimes you put a particular plant to the idle mode, maybe for 6 months or a year, you're not using that pressure vessel, right? Let's say you've got a big air receiver, right? That has been in idle. What's happening is, over a period of time, there might be condensation happening inside that receiver, and it may cause some corrosion, right? But now you want to again put that particular pressure vessel or plant in operation. What's going to happen is you say, all right, this hasn't been really in use. We may as well just press the start button, no problems. And as soon as you start button, it goes bang. Why? Because there has been corrosion. You haven't been aware of that happening, and it's been a very passive process. So really important that we actually just keep an eye on the idle equipment, if there are any preserving actions that we can put in place to ensure that over that idle period, again, the integrity of the vessel is intact. And then we've got the inspection of remaining this inspection for remaining life of a pressure vessel. So again, in some occasions, we do allow some, as an example, corrosion to happen on the external walls of a pressure vessel, right? But then, as the corrosion occurs, right, the remaining life of that vessel starts to shorten, right? So it's pretty important, again, while you're maintaining an eye, or you're keeping an eye on the corrosion rate, you have to have a very good idea as to how much longer you can actually have this pressure vessel in operation without having any, obviously, catastrophic failure happening there.
So provided that there are no fires, we've put the accumulator into service, it's all operating beautifully, what would be the next periodic inspections that we would have to do that you've already spoken about?
Yeah, so periodic inspection regime is very much stipulated in AS 3788. On the table 4, they tell you for different types of vessels, what inspections you have to have in place, right? So let's start with what is most relevant to our industry, being fluid power industry, and have a look at the hydraulic accumulators, for example. Under point 10.1 in table 4 of AS 3788, the standard suggests some inspection regime for different pressure and volume oriented accumulators. So really it suggests for, if you've got a smaller accumulator with a PV value, which is the result of multiplying pressure in volume, for PV value less than 100 megapascal, they suggest a particular interval. For PV value between 100 and 200 megapascal liter, they suggest another inspection interval. And for PV values greater than 200 megapascal liter, they suggest another interval. So let's take a 50 liter hydraulic accumulator as an example with a design pressure of 400 bar. So clearly that PV value is greater than 200 liter. So then we take that to that table 4, and we look at the inspection interval required. First and foremost, you do require to conduct a commissioning inspection on that. So we spoke about commissioning inspection, why we have to do it. The second one is first yearly inspection. Yes, we do need to run a first yearly inspection on the accumulator, and what that entails is both external and internal inspection of the vessel. Then furthermore, you're going to have to run external inspections every second year. So looking at the outside condition or external condition of the pressure vessel and tick all the boxes. And obviously each inspection comes with their own report systems, documentation, and everything, right? And then you've got the internal inspection intervals. Every 12 years, then you are obliged to actually run an internal inspection, and under certain circumstances that interval inspection intervals can be extended for a certain number of years.
So for the yearly inspection, pulling apart accumulators would be a timely and costly exercise. Is there a way to mitigate this or postpone this if the system is running in an ideal situation?
Well, you can't quite skip the 12-year one. At certain point you have to pull it apart. But the standard is calling for first yearly inspection, right? So this standard, it's very important to remember that this standard is applicable to pressure vessels starting from a small, 1 liter diaphragm accumulator all the way to multi-megawatt boiler or huge air receivers and larger items of the plants, right? So for a boiler, maybe, or for an air receiver, it's quite important that you actually do it after a year, right? And so it's for a hydraulic accumulator. If you're not sure what the process is doing to your particular pressure vessel, right? Let's say we put an accumulator working on a corrosive medium, right? And you're not 100% sure what that corrosive medium is doing to your pressure vessel. So after 1 year, you pull it apart, you look inside and say, all right, yay or nay, it's looking good or it's not really looking good. You have to put some extra measures in place to protect it against corrosion, right? But what if you're 100% sure that the pressure vessel, it's a very, very costly exercise to pull a brand new vessel apart after a year, right? Just to to run an internal inspection. But what if you're 100% sure that nothing's going to happen and the pressure vessel will be intact after the first year? Not only that, just moving on for the next 10 years, nothing's going to happen to this vessel internally. So the standard suggests an inspection method by the name of risk-based inspection. So risk-based inspection is really an alternative method, or it's not an alternative method, it's an alternative to inspection intervals listed under Table 4 in AS 3788, right? And what it's about understanding the risk associated with varying the intervals identified in that particular table, right? So what you do and what that process of risk-based inspection involves is, first and foremost, you have to get everyone to agree. It's very, very important. There are different stakeholders around a particular pressure vessel. The owner is one, right? The inspector is another one. The engineers running the plant is another one. And in a larger plants, it actually might be some more significant number of stakeholders, like maintenance managers, it can be like operation managers, it can be everything, right? It can be everyone. So it's very important that everyone actually agree to use a risk-based inspection as an alternative to the periodic inspection interval suggested by the standard itself. Then what we're going to have to do is we have to prepare a risk assessment and management of documentations to justify any variations of inspection that the standard has stipulated, right? So in simplest terms, what that means is we have to have a look at the risk associated with not running the first yearly internal inspection. What can potentially go wrong, right? The severity of risk, the impact of that on the actual plant itself, and whether in fact there is any particular process detrimental to the life of a pressure vessel, right? And then we involve a multidisciplinary team, whoever is the stakeholder involved in that process, to get their opinion. Maybe running an internal inspection on a particular pressure vessel is a very costly exercise, but the maintenance team says, actually I don't mind, right? If something goes wrong, they do a risk assessment and say, all right, if something goes wrong, first of all, it's not going to have any impact on anyone's life or health or anything as such. So I can actually just replace that with a risk-based inspection type process. Then the operation manager comes and say, actually, hang on. Yes, you may have a spare one that you can swap it over, no problems for you. But from my perspective, right, it may cause X amount of financial damage because we have to shut down the plant. Then the OH&S manager will come and say, hang on guys, we cannot just overrule the standard because it may have some impact on the life of the person around and the health of the property and everything. But if everyone's happy, if everyone signs off on that inspection document and the agreement that, all right, under no circumstances there's not going to be any threat to anyone's life, the integrity of the plant is going to be maintained, there's not going to be any impact on a shutdown process, there's not going to be impact on the maintenance time, etc., then we can overrule or replace what's suggested in AS 3788 as the inspection interval with a risk-based inspection plan. So again, it's very important that whatever plan we come up with, the inspector involved in inspecting that plant sign off on that plant. And if there is any concession around not doing the routine interval inspections, and we have decided to change it to a risk-based inspection. That's been agreed by the inspector in charge for, inspecting that particular part of the plant as well. So yeah, that's about it. Really, that's pretty much. I mean, there's a lot involved in different methods of inspections. The NDTs and the hydrostatic pressure testing and the personnel who can do the inspections, etc., etc. And it's quite a comprehensive topic of discussion. If anyone's interested in finding out more about this particular process, obviously they can talk to pressure vessel inspectors in their areas. They can contact us for further clarity and information, or they can purchase a copy of AS 3788, which offers quite a extensive amount of detail on this particular subject. Have a read through and get a good understanding of what's involved. But anything that we can help, feel free to give us a call.
Thank you, Ali. Thank you very much for your time. And thank you, everyone, for tuning in to part 2 of Hydac's hydro-pneumatic accumulators. Thank you. Thanks for joining us on this episode of Hydac Podcast. For an in-depth learning on the subject you've just listened to, enrol on the technical training at Hydac Australia. For more information, visit our website, hydac.com.au. Hydac. Global presence, local competence.